in this example, it's a bit trickier than the other ones that we've done before because you have some number in front of x squared. Whereas in the table that we made, all of the x squares just have x squared by itself. It doesn't have any constant multiplied to it. So we have to think about how to deal with this 9. And the way you get rid of it is, do you have an idea?
Well, since we know x, can we just distribute it into it? You get what I mean?
No, I don't get what you mean. Okay, I'll just keep it. Okay, so you want to forcefully get rid of this 9 by dividing top and bottom by this number. Okay, so what you want to do is you want to divide the top and bottom by 3. Oh, by the way, there's a technicality here. We're going to assume that x is bigger than 2/3. Okay, it's just some technicality so that you don't have to put lines there. So you don't have to worry about this. All I want is that at some point this will come down. All right. So I divide top and bottom by 3. And why did I divide top and bottom by 3? Because when 3 goes inside the square root, it becomes 9. Right? So top will become 2. Whereas inside the square root, you have 9x squared over 9 minus 4 over 9.
Was that a number you chose, just 3?
I chose this 3 because why?
Because if you plug it into the
Because when it goes inside the square root, it will cancel the 9 away. And you will end up with 2 over square root of x squared minus 2/3 squared dx. Okay. Yes?
So the x squared can't have a coefficient, so you couldn't just use like 3x squared in parentheses minus 2 squared.
Actually, that's a very good point. So another way to approach this would be to rewrite this as 3x squared minus 2 squared.
That's what I was trying to say.
Oh, that's what you were trying to say. Actually, yeah, that's actually quite good. You can do it this way and then say 3x is equal to, it's this one, right? You can write it as 2 secant of u. Well, actually, I like this better. Because then you end up saying x is 2/3 secant of u, right? Okay, but since I started this way, doing this way will make it slightly different, but at the end of the day, it will be the same thing. Notably, this will be a little different, but let me just continue on this way, okay? But definitely, you're right. You can do it this way, and then at the end of the day, the result will be the same. Okay, so this, because it corresponds to this case, it suggests that our change of variable must be x equals to 2/3 secant of u, where dx is 2/3 of what? We're differentiating both sides, right? So what do you get? Right, secant of u, tangent of u, times d, u. Okay, and then furthermore, we know that square root of x squared minus 2/3 squared. Well, I have it in the table here, but you really want to be able to calculate that. Okay, so plug this into x so that you get 2/3 squared secant squared of u minus 2/3 squared. Right? Then you can bring the 2/3 outside, which will leave you with secant squared of u minus 1. And because 1 plus tangent squared is secant squared, if you subtract 1, you get secant squared minus 1 equals to tangent squared. So this just becomes 2/3 of square root of tangent squared of u. And then square and square root will cancel and introduce an absolute value, but this additional condition will allow us to say that this is always positive, and therefore you can just write down 2/3 tangent of u. Okay, so we have everything needed for doing the u substitution. It's 2 over, this denominator now becomes 2/3 tangent u. And then dx gets replaced by 2/3 secant u tangent u du. 2/3 cancels, tangent u cancels, and 2 can be pulled outside the integral, which leaves you with this integral of secant of u du. And we have the formula here, right? It's 2 ln of secant of u plus tangent of u plus c. Okay? Is that the answer? Not yet. Why?
You have to still plug in the x.
You still have to convert this into an expression in x, right? And at least for secant of u, I know what to do. What is it? Solve this for secant of u. Flip, right? What's that? 2 ln of 3 over 2 x. How about tangent of u? This one here, right? Tangent of u times 2/3 is this one. So if you solve for tangent of u, it's 3 over 2 of square root of x squared minus 2/3 squared plus c. Okay. So that's the answer. However, what I want you to try is like, there's a division by 2. So that's like minus log of 2 that can be split out, and then you can redefine the constant so that that can be written away. So that can be absorbed into c. And if you do that, a fully simplified answer will be something like this. You get 2 ln of 3x plus 3 times, no, 3 will go inside as 9, so it would be 9x squared minus 4 plus c, and then I remove the absolute value because this condition will allow this to be positive. So that's the fully simplified answer. On the exam, if you just stop here, I'll be giving you full credit.